Hey guys, in this video I'm going to introduce the torque lab, which we will do during our next class. So we want to study the following very simple situation. We have a bar. This bar has some mass m. And we have a variety of forces acting on this bar in various locations and with various angles. For instance, this bar has mass, so it definitely has a gravitational force. But let's say we're also pulling on it in some way. So there's some force at some angle. So we want to understand how the angle changes the torque that this force is imparting to the bar, and also how the location of that force, which starts from right here, how that changes the torque imparted to the bar. So for instance, if I have an axis of rotation, which is right here, the distance to that force is some distance d. What happens to the torque on the bar if we change that, and what happens to the torque of the bar if we change that? Okay, so here's the experimental setup for this lab. This is a 2x4 attached at a point of rotation to the table. And on the 2x4 we have some strings at evenly spaced locations. So, first thing to notice is that the center of mass of this bar, which is something like here, this is a massive bar. So there's a force due to gravity on it, and acting on the center of mass, which is not at the point of rotation. So gravity wants to pull the bar down, it wants to torque the bar to spin it. If I hold here, then I can put a force on this bar, which is causing a torque at a radius between the point of rotation and the point of application of the force. That force is causing a torque, offsetting the torque due to gravity, and making this bar stay stationary. So how much is that force? Well, we can answer that question because we have these analog force sensors. So hook the analog force sensor up to the string, and I can read right off the force sensor how much force is required to cause a torque at this location to offset the torque due to gravity. I can change the location of that force, and I can measure a different force. So I can determine what the dependence of the distance is on the force that I have to apply to offset the torque due to gravity. In addition, so I can try that at all these various locations. In addition, I can see that if I change the angle of this force with respect to the bar, that I have to pull harder and harder. So how exactly is that angle dependent on the force is also something we're going to ask you to do in the lab. So we're going to ask you to first measure one location, measure the force at one location. And then based on how much force that takes, we're going to ask you to predict how much force it will take at each other location. And then we're going to ask you to confirm that, just measure, make sure that it works. And then we're going to ask you to measure the force at one location, and then change the angle, take a protractor down here, measure the angle, and predict what force is going to be required at each angle, and then use the bar and confirm. So that's going to be the lab. Pretty straightforward, but I hope that it will give you a better idea about how the distance and the angles of a force acting on a bar change the torque. Okay guys, thanks for watching the video, and I will see you in class to do the lab.